This time-lapse reveals a physical limitation. Our most powerful sense is tied to materials that actively decay. A vibrant flower blooms, releases its essential oils into the surrounding air, and then rapidly fades to dust. For early humans, the only way to generate an intense smell on demand was to destroy the source. They gathered raw resins and woods, then burned them to force the trapped odors out. The word perfume actually comes from the Latin perfumum, meaning through smoke. This carved alabaster vessel from ancient Egypt highlights the reverence early civilizations held for these aromatics. The Egyptians created a complex mixture of 16 ingredients called kaifi, viewing the resulting aroma as the sweat of the gods, a sacred, temporary offering. Yet humans wanted to hold on to those scents. We wanted to wear them, travel with them, and prevent them from dissipating into the atmosphere the moment a ritual ended. Shifting scent from a vanishing cloud of smoke into a permanent, wearable liquid meant learning how to catch a vapor. That specific technological quest drove the early history of chemistry. The first recorded chemist in history was a Mesopotamian woman named Taputi. Around 1200 BC, she developed methods to extract aromatic compounds from flowers and suspend them in heavy oils. This schematic shows an alembic, a distillation tool perfected by physician Avicenna. Heated botanical matter forces aromatic steam upward. The vapor routes into a cooling tube, condensing into distinct drops. This successfully separated heavy essential oils from rosewater, trapping the flower's pure essence. While he captured the scent in liquid form, these heavy oils sat flatly against the skin. They lacked the volatility to project into the air, meaning fragrance remained a personal, close-range experience rather than a radiating presence. During the Crusades, these Eastern distillation techniques traveled along trade routes back to Europe. By 1370, this knowledge led to the creation of the Queen of Hungary water. The creators of this water achieved a significant chemical upgrade by replacing dense, heavy oils with ethanol, an alcohol base. This model of the skin's surface shows why alcohol works so well. Left, heavy oil molecules remain static. Right, alcohol molecules rapidly detach. Ethanol evaporates at human body temperature, lifting the scent molecules off the skin and into the air. This evaporation engine created a projecting scent cloud. Renaissance France utilized this mechanism to mass-produce concentrated fragrances, used specifically to mask the odors of an era that largely avoided bathing. This vintage postcard of the tuberose fields shows the sheer scale of the resulting industry. Grasse became the manufacturing capital of the world, relying on huge swaths of farmland and intensive manual labor to harvest jasmine, lavender, and roses. But an economic bottleneck remained. Perfume production was strictly limited by the physical yield of nature. It required literal acres of flowers to produce a few tiny vials of luxury extract. In 1882, the perfumery Hubigant released a fragrance called Fougère Royale. It contained coumarin, a synthesized molecule created in a laboratory. Synthesizing molecules bypassed agricultural limits, which plummeted the cost of raw materials. It also allowed chemists to invent abstract smells that do not exist in the natural world. This is François Coty, known as the father of modern perfumery. He recognized that laboratory synthesis could scale production, and he ensured his marketing and packaging matched the new science. These intricate metal and glass bottles show Coty's collaboration with master craftsmen like Lalique. They turn the packaging into a piece of art, elevating the value of the synthetic liquids inside. In 1921, Coco Chanel disrupted the market by requesting a perfume that smelled like a woman, not a flower. Her perfumer achieved this by using a high concentration of synthetic compounds known as aldehydes. This minimalistic glass bottle holds Chanel No. 5. The use of aldehydes gave the liquid a clean, abstract profile, establishing a new standard for what a modern fragrance could be. Synthetic molecules untethered scent from the soil. Perfume evolved into a scalable, industrial art, independent of the seasonal harvest. This Dior promotional image from the mid-20th century shows the results of mass production. Scents moved off the pedestals of high society and onto the vanities of the middle class. Today, the market has seen a swing back away from mass appeal toward exclusivity, driven by the rise of artisan, niche perfumery. A moment of wonder. This macro shot of rain hitting dry pavement represents petrichor. Modern chemists use advanced molecular science to recreate exact, emotionally triggering memories like this, or the scent of old paper. By relentlessly pushing the boundaries of chemistry to solve the problem of the fading flower, humanity engineered.
Ruta olfativa. Descubre tu aroma.